Welcome. We are going to start our live class on complex number. So first of all, I will try to introduce what is a complex number. Let us see why solving this equation x square plus 1 equals to 0. What we are getting x square equals to minus 1. And we are knowing that a square quantity can never be a negative quantity. Hence, finding no solution of this one. From here, it is required for mathematics to make some new assumptions, a new type of numbers. It requires to extend the domain of numbers. So we assumed that, so what we are getting from here, x equals to root of minus 1. And if we can assume this is equals to I, what we are getting, x of root of minus 4, we can write it as 2i. Root of minus 5, we can write as I root 5. In this way, if we can make only one assumption, it can solve all these negative numbers inside root. We can find the solution for those things. Now, the interesting thing in this assumption is that these assumptions are obeying laws of algebra. As algebra we are doing, 5a plus 2a equals to 7a. Here also 5i plus 2i will be 7i. If algebra we are doing 3a into 2a equals to 6a square. Similarly here 3i into 2i equals to 6i square. So it obeys by this assumption it obeys all laws of algebra. That's the most important thing, and this assumption obeys the laws of all algebraic laws. Now we can say that complex number is generally expressed as a plus ib. Here a and b are real numbers. A plus ib, when we are saying a and b are real numbers. Suppose we are writing 2 plus 3i. Here 2 and 3 are real numbers. 5 minus 7i. 5 and minus 7 are real numbers. So general expression is a plus ib. So in this, a plus ib is a complex number. Generally we are denoting it by z. Then this is called conjugate z. Conjugate of z will be a minus ib. Remember, if it is there somewhere that I plus 5, okay, its conjugate, if you are writing I minus 5, so this is a wrong thing. It cannot be the conjugate of this one. If you are writing, you have to write it in the form of 5 plus I, and then you can say 5 minus I will be the conjugate of this one. You write in this form, a plus ib, its conjugate will be a minus ib. So in this way, these are called complex numbers. So in complex number, think it, suppose 5 plus 5 plus I, that is 5 plus root of minus 1. Can we add these two? This cannot be added. So there cannot be addition between real and imaginary parts. They are separate. There cannot be an addition, there cannot be any subtraction. So from here, we will try to remember certain properties of complex number. You have to try to remember these properties of a complex number. If a plus ib equals to c plus id, if a plus ib is a complex number and c plus id is a complex number, from this equation, what we can find that these are called, A is called the real part. We are saying real real of A plus ib equals to A. Similarly, we are writing imaginary part of A plus ib is equals to B. B is the imaginary part. Now, what we are saying, so what we will say, real part equals to real part. From this equation, this is a complex number, this is also a complex number. If these two numbers are equal, from here we will conclude that A equals to C. That is real part of A plus IB equals to real part of C plus IB. And B equals to D. That is imaginary part of this equals to imaginary part of this. This is a property of a complex number. And if A plus IB equals to 0, this is possible when A equals to 0 and B equals to 0. So from here we will conclude A equals to 0, B equals to 0. This will be the obvious conclusion from here. Now, the properties I will say, try to understand, and if you can remember, you will get some advantage. If you can remember, you will always be in advantageous position. The algebraic sum, difference, product and ratio of two complex numbers is always a complex number. The sum of two complex numbers will be a complex number. The difference of two complex numbers will be a complex number. The product of two complex numbers will be a complex number. The ratio of two complex numbers will also be a complex number. And any power of a complex number will again be a complex number. Remember one thing, while learning complex number, when we are saying A plus IB, there is a possibility that B equals to 0. If B equals to 0, then that means it becomes A, then it becomes a real number. So real number is a subset of complex number. Real number also come within the domain of complex number. All numbers, whatever is there, everything is coming within complex number. And if A equals to 0, then it becomes IB. It is a completely imaginary number. So that is also a complex number. All real numbers are complex numbers. So whenever we are saying that sum, product, etc. is a complex number, that means it includes the scope that those may be real numbers. Real numbers are also complex numbers. the sum and product of two conjugate complex numbers. What we said, conjugate is, suppose z equals to a plus ib, and its conjugate will be a minus ib. Their sum will be 2a. It will be a complex number. Their product will be a square minus I square b square. That is a square minus I square b square. And I square is minus 1. Hence it becomes a square plus b square. It's also a real number. The sum and product of two conjugate complex numbers is a complex number. Okay. The sum and product of two complex numbers, as I told, it's a purely real number. This is also a purely real number. These things you have to remember. Now I will try to show you a geometric explanation of this one. That is known as Argand diagram. Geometrically, how I will explain these things. Listen it, suppose this is A. If we are knowing that if we are turning it through 180 degree, then it will come here, it will become minus A. Okay. Turning it through 180 degree, A will reach here. Okay. And if we are turning this one through further 180 degree, it will reach here. So if we are turning A through 180 degree, it will become equals to A into minus 1. That means turning through 180 degree, we can say it is equivalent to a product of minus 1. And we are knowing I into I equals to I square equals to minus 1. From here, we can say that this is a comparison. That means if we are rotating it through 90 degree, it will become I. So if we are rotating it through 90 degree, it will become IA. If we are rotating it to minus further 190 degree, it is becoming I into IA, that is minus A. Again, if we are rotating further 90 degree, it will become minus IA. And further 90 degree will again make it A. So in this way, we can say the number line, this is called the real axis. This is called real axis. And this one we are saying an imaginary axis. Imaginary axis. That means any point on this line, as you are knowing in this number line, any point on number line is a real number. And if we are drawing a perpendicular line, then any point on this line will be an imaginary number. Let us assume that here is a point P. Let us assume its Cartesian coordinate is xy. Then what it means, if this point is O, that means this length is x, this length is y. So following the vector style, this vector plus this vector equals to this vector. We are following the vector style, so we are writing x plus iy. So this point will be denoted by x plus iy. Okay, and see in this way. So what we are saying, the difference is coming. That means what we have said earlier. What is a real number? A real number is that which can be expressed by any point on the number line. Or conversely, we can say every point on the number line represents a real number. Now for complex number, we are getting a plane, xy plane. In this plane, any point is a complex number. Any point on this plane is a complex number. So the point which belongs to this real axis is also there. So that is also a real number, is also a complex number. So from here, what we are getting, see, if we are using this one, I am not knowing, but if you are not knowing, you have to know it. Today or tomorrow, you have to know. This is called, this we are saying in form of Cartesian coordinate. Here, if we are writing in polar coordinate, and this angle is theta, this is r. This is called polar coordinate, where we are expressing a point by r theta. R and theta we are using, we are expressing this point by r theta. From there, what we can write, x equals to r cos theta. That means you are knowing cos theta equals to base by hypotenuse. That is cos theta equals to x by r. So x equals to r cos theta. Similarly, y equals to r sin theta. From here we are getting x square plus y square equals to r square. That is r equal. From here we can say r equals to root of x square plus y square. This r is known as the modulus of this complex number. The complex number is x plus iy. If x plus iy is the complex number, its modulus will be this one. R equals to this one. And we can write tan theta. That is, see, from here x by y, y by x. If we are writing y by x, it will be r sin theta by r cos theta. R will cut. What remain will be tan theta. So in this way, we are getting a relation x plus iy. We are writing this number. We are writing in this type. X is x plus iy. X equals to r cos theta plus I into r sin theta. So taking r common, we are writing cos theta plus I sin theta. So this is the expression of x plus iy in polar form. These things you have to remember. Now I will say you certain properties. My voice is not that much good. I am becoming old, but try to remember. I cannot write everything. Try to understand and remember this thing. What are the properties of modulus and amplitude? Let us assume there are two complex numbers. Z1 equals to R1. Or we can say Z1 equals to A plus IB, and Z2 equals to C plus IB. It may be in any style you can write. Then what is given there? And there, as I have shown you, its modulus is greater than R1, its modulus is R2. If we are writing into in this form, R into cos theta plus I sin theta, then R is known as the modulus. So let us assume their modulus is R1 and R2. Now the properties are modulus of the sum. Modulus of the sum. That means modulus of Z1 plus Z2 is either less or equals to modulus of Z1 plus modulus of Z2. These things you have to remember that modulus of the sum is either less than or equals to sum of the modulus. Similarly, modulus of the difference will be greater than equals to modulus of Z1 minus modulus of Z2. Remember these things, this will help you to solve lot of questions. And modulus of product, that is modulus of Z1 Z2 is equals to modulus of Z1 into modulus of Z2, ratio of two complex numbers. Then their modulus will be modulus of Z1 by modulus of Z2. If you can remember these properties, you will get help in doing sums will become easier. Now, amplitude of product. Amplitude is theta. As when I have said tan theta equals to y by x or theta equals to tan inverse y by x, theta is known as amplitude. Amplitude of product. Remember this one, amplitude of product of Z1 Z2 is equals to amplitude Z1 plus amplitude Z2. Amplitude of product is sum of their amplitudes. Again, amplitude of ratio Z1 by Z2 equals to amplitude Z1 minus amplitude Z2. When we are saying minus, it is not the actually the difference. Which one may be greater? Actually, the term is difference between Z1 and Z2. Okay. So these are some important properties of the modulus of complex numbers. Now, I will discuss one more thing. Those who are just joining class 11, for those it will be difficult, but this chapter is there, it is 11, it is there in BSc. For everyone, I have to say something. 11, you will learn it afterwards, those who are knowing. So, that is called de Moivre's theory. What is de Moivre's theory? De Moivre's theorem says cos theta plus I sin theta. As I expressed, this is a form of complex number expressing a complex number whole to the power n. Cos theta plus I sin theta whole to the power n equals to, see it carefully, it is cos n theta plus I sin n theta. I am not showing the proofs. In this time span, it is not possible to discuss everything. But what we have to remember, cos theta plus I sin theta whole to the power n equal to cos n theta plus I sin n theta. And one more thing, you will know it. Those who are not knowing, they have to know it. In course of time, you will be able to know it. And e to the power I theta, e to the power I theta can be expressed as cos theta plus I sin theta. These things you have to remember. This is called cos theta plus I sin theta whole to the power n. Then it becomes cos n theta plus I sin n theta. And e to the power I theta can be, what is e? That I will know afterwards. In a single class, I cannot explain everything. This one also you have to remember. One more thing I want to show you, little bit elaborately. Let's these things again I am repeating. You have to remember these things. You will get lot of advantage while doing sums. Now see, if we are interested to know the cube root of 1, that is 1 to the power 1 by 3. What is the value of cube root of 1? We can write it in this style also. Cube root of 1. In lower classes, we have done it. That cube root of 1 is 1, square root of 1 is 1, square of 1 is 1. In lower classes, we have done it. But in higher classes, we have to see it more carefully. Cube root of 1. We are assuming this is equals to x. So see carefully. Can we write x cube equals to 1 or x cube minus 1 equals to 0, or we can write x minus 1 a cube minus b cube formula into x square plus x plus 1 equals to 0. From here we can say x minus 1 equals to 0, and from here we are getting x equals to 1. This is called the arithmetical cube root of unity. That is arithmetical cube root of 1, which you are knowing from much lower classes. Now we'll think about this part. So this one, x square plus x plus 1 equals to 0. You are knowing Sridhar Acharya's formula for this quadratic equation. X equals to minus b plus minus root of b square minus 4ac by 2a. This will be the solution. That is what we are getting, minus 1 plus root of minus 3 by 2. Another we are getting minus 1 minus root of minus 3 by 2. We are getting two solutions. Hence we are getting three solutions of cube root of unity. One is the value is one answer, this is another, this is the third one. These are the three solutions we are getting. Remember, we will learn slowly that when the maximum power is 3, there will be three solutions. If the maximum power of the unknown quantity is 5, there will be 5 solutions. And in course of time, if it is required, as the viewers are requesting, I am doing this class choosing the chapter based on the viewers' request. Based on request, we can do further higher classes to how to utilize these different powers. Now let us see one interesting thing. I think you can see this one. If we are assuming this one, this symbol we will use as omega. Omega equals to this one, minus 1 plus root of minus 3 by 2. If we are doing whole square, so what we are getting, omega square equals to 1 minus 3 minus 2 root minus 3 by 4. That is equals to minus 2 root minus 3 by 4. Cancelling by 2, what we are getting? Minus 1 minus root of minus 3 by 2. See, we got this one. So if this one is omega, then this one is omega square we can write. If this one we are writing omega, this one will be omega square. And you can do in your home if you are considering this one as omega. Okay, I am showing you. If you are considering this one as omega, omega equals to minus of 1 plus root of minus 3 by 2. Then what will be omega square? Omega square will be 1 minus plus 2 root minus 3 by 2. Sorry. Then it will become by 4. So this will become minus 2 plus 2 root of minus 3 by 4. Cancelling 2, what we are getting? Minus 1 plus root of minus 3 by 2. That means you are getting this one. If you are considering omega is this one, you will get this one as omega square. If you are considering this one omega, you will get this one square. In real number, it's absurd that if 2 square is 4, 4 square can never be 2. But in complex number, this one square is this one and this one square is this one. Okay. So in real number, you can get it only for 1. 1 square is 1 and 1 square is 1 anyway. So these two different numbers, this one square is this one and this one square is this one. So what we are getting, therefore, there are three solutions. There are three solutions of cube root of unity. One is called 1 omega and omega square. These are the three solutions you are getting. And if you can do 1 plus omega square, what will you get? 1 plus minus 1 plus root of minus 3 by 2 plus minus 1 minus root of minus 3 by 2. This one you are getting 2. 2 minus 1 plus root of minus 3 minus 1 minus root of minus 3. So 2 minus 1 plus everything is cutting, so equals to 0. So what you have to remember, 1 plus omega square equals to 0. This property of cube root you have to remember. Cube root of 1, that is 1 plus omega square equals to 0. And see then, from here you can see omega to the power 1 equals to omega. Omega square equals to omega square. Omega cube equals to 1. Omega to the power 4 equals to omega cube into omega, that is omega. Omega to the power 5 equals to omega cube into omega square, that is 1 into omega square. In this way, omega to the power n for any integer, it will be either of the three. Omega to the power n, it will be either of these three. And one more thing there, so these things you have to remember. Just I will show you. What about I? I equals to I square equals to minus 1. I cube equals to I square into I minus 1 into I minus I. I to the power 4 equals to I square whole square, that is 1. So in this way, I to the power 5 if you are doing, it will be I to the power 4 into I, so equals to I. So I to the power n, I to the power n will be any of these four, either plus 1 or minus 1 or plus I or minus I. Thank you. You have bear me for such a long time. I tried to explain some important things of complex number. Hope I can able to communicate to some extent. If whenever you require any class, you can mention. Accordingly, in the next class, we'll discuss about that portion. Thank you for remaining with me for such a long time.